Hey guys, welcome to another episode of Introduction to C++. With me, George Wulfers. Um, so yeah, I've been MIA since May apparently, and I'm back. Hopefully, this video comes out good and I like it and I don't redo it. And I don't know if this might be the time that I actually, nail it. But I want to talk about pointers. Now, pointers can be really difficult to understand when you're a beginner. It took me a while to be able to be comfortable with pointers and with anything pretty much with programming. So if I don't do a good job on explaining it, it's because it's a I don't know. It's kind of complicated. Can be complicated. So yeah. Sometimes I'm not the best at explaining things, but I'll do my best. So if you want to follow us today, go ahead and go to my GitHub repository and download this version of it. That's what we'll be using to create a new project. Okay, I already created my project. It's called IntroToCpp pointers. Make sure you set as startup project when you create a new project here, and make sure to add your CPP file. Okay. So pointers, yes. Alright, so we all remember that how to create variables, correct? It is just as simple as saying int variable name equals something. Here we are declaring and initializing our variable all at the same time. Now variables like this are stored in a memory space that's called a stack. And so they're not in the memory space called the heap, which yeah. Anyway, so what is a pointer? A pointer is kind of like a variable, but it does not hold values. It doesn't hold values like 10, right? It only holds memory addresses. So let's jot that down. So pointers hold memory addresses. Where data is stored. Okay? Now there are several ways. Well, there's one way, not several, of defining a pointer. So to define a pointer, we do just like any variable. We start off with a type, and we put in a little star before the name, and we just name the pointer. It's the only difference is the little star, right, in here. So this lets us know that this is a pointer. Now, in order to use a pointer, we have to allocate memory. So if we were just to say if we wanted to do that, we can't. We can't just set it a value like this. Okay? We have to set something that is already allocated for us. Now, we can set, let's say that we wanted to use this variable, right, as the address. Now, if we just set it like this, it's not going to work. In order for us to get the address of this, where this value 10 is located in memory, we just have to put an n% right in front of it. This gets the memory address where the value of variable name is. Okay? So pointer store pointer store address, memory addresses, and those memory addresses contain, you know, data, values. That's how we store stuff in our in our memory. So in order for us, if we were just to do, let's include a IO stream right here. Right? If we were just to do a cout, let's say we wanted to print out the pointer right here, and if we just do this, when we run this, we're not going to get 10. We're not going to get the value of that variable that we set it to. We're going to get the address of memory where the value 10 is being located at. So if we were to copy that address into our memory window right here, oh, we can't yet. We have to actually do this and then press a key. Alright, so if we wanted to get this pointer, we can just say, if we don't know the actual address, we can just say ptr name right here, and it'll show us the actual pointer where it's pointing to, we can see that here if you remember, integers are 32 bits, and the whole this is our whole pointer variable right here. We only have stuff in the in this section of the integer, and these are just zeros because the only thing we have is a 10, and in hexadecimal that's a 10. A is 10. So we can see that we have the address right there, and if we go back we can see that these two match right there. So if we just use the name of the pointer by itself, we're going to get the address. Now if we also just look at our variable name, well, that is not here, but if we, because it's not a pointer, if we get this, if we get the address of it, we're going to see the same address, because this guy, our pointer name, is pretty much pointing, it's telling us that he is looking into the variable's name memory space, which holds the value 10 right here. Okay, so you can see why this can get a little confusing. If you actually want to get the value that this pointer points to, we have to do something called dereferencing. So in order for us to actually work with the data that the pointer points to, we just have to do this. We just gotta put a star right in front of it, and this is dereferencing. This will go into that memory space, that address, and it'll fetch out that integer, that value. So if we would run this once more, we can see in our printout that we actually get the value 10, where this address is pointing to, or where the pointer is pointing to that address, or that holds that value. So you can see why this can be a little bit confusing. And pointers are very useful in C and C++. They let us do a lot of stuff like manage memory. So if we wanted to, we could allocate a certain amount of memory for our program and use that memory to allocate game objects if we were making a game or some other stuff. Anything that we have to store throughout the lifetime of the game. Any data. Also, pointers. Let's say we have let's just do a regular function here. Let's say that we have a function called, I don't know, we'll just call it foo, and it takes in an integer, and we'll just call it a, and we want to change this variable. If we do this, if we call foo and we pass in the variable name, from just looking at this one, we're gonna suspect that when you pass in the variable name here into this function, we're gonna expect it, when it comes out, to be 20. And we can actually see here, if we were to print this out, that if we just use a regular function with a regular variable name, it does not change it at all, right? So, okay, if we do want to change it, we have to use a pointer. We'll just overload this foo and we'll do that. Right? Now remember that to be able to set a value to this pointer, we can't just do a equals 20, because a talks about the memory address, so we have to dereference this to be able to talk about the actual value where this value is being stored in memory. So if we were to use this instead, we just have to change it a little bit here. We just gotta pass in the address of this variable name in order for us to be able to see it as a pointer. And if we were to run this one more time, we can actually see that it changes now, right? Instead of giving us a 10 again, it just changes that value into a 20 right here. That's where we're printing it out. That's where we're changing it. We're using this function now. So how does this work? So in here, this function, the reason why it's not changing anything is because when we pass a variable into this function, since it's just a regular variable, it's going to create a new variable. It's going to copy the contents of whatever the variable name is or whatever we pass it, and it's going to create a new variable in stack for this function, and it's just going to set that to 20. If we do want it to use this guy without a pointer and we wanted to change it, we would have to return a, right, for us to be able to change that. And we're just going to change the return type to an int, and this is how we would normally change it without a pointer. So we would have to do this. And this would get 10, copy it into this int a, then it will return int a. We would have to catch that int a for us to be able to actually change it like that. Okay. Now let's say that we didn't want to just return a, we wanted to return something else, like a boolean or whatever, to see if it actually worked, but we wanted to modify some values. Then we would use the other option. Like this, we would use the pointer here. Now this is not creating a new variable at all. This is getting the address of whatever we pass it, and it's using that same variable, that same memory space as the variable that we want to change, and then it just changes it directly. This is indirect because it creates a new, new memory in the stack, and then just returns that. While this gets the same memory footprint, and we just change it directly through here. Now, you want to be careful, because sometimes you don't want to change something, and just be careful with pointers. If we were to use a pointer that is not initialized, be very careful, because you will crash, and we'll say this right now. So let's say we just initialize, we just declare that pointer, and we don't initialize it at all. We don't initialize that memory. Well, we're gonna get this. In this case, it failed. But if we were to initialize it to 0, I think it'll actually run it, but it'll crash because there's no memory to work with here. It says reading violation, reading location 0, because there's no memory in there. And if we were to debug this, we can see it in here. There's no memory. If we go to the memory and we put pointer name like we did before, we can see that it's non-existent, and we just get all kinds of nothingness right there. So when you start using variables like this, pointers, not variables, when you start using pointers, make sure when you always declare a pointer, make sure you always set it to 0. This way you will know exactly where you're gonna fail. Otherwise, if we were just to do this and it does compile, let's say, right now it won't compile because we didn't set it to anything. If it were, some other compilers would just be like, okay, yeah, that works, but then it would crash, and you would have a harder time knowing where the problem is if you don't set it to something initially. Now, if we wanted to create a new memory for this, we can use something called the Malloc or new. Malloc is more for C. I use Malloc or virtual Alloc a lot in my programs. So let's say we wanted to make a new memory location here. And this will create new memory. Let's say we just want enough size in bytes here for an integer, and this malloc function returns a void star, which is a generic pointer pretty much. So if you have a int pointer, you want to cast it to that so it knows I guess, the layout of that memory that you're using. And then here, when we use it, we wouldn't crash anymore. Wait, well, don't run it yet. Make sure that if you allocate anything here, we always have to free that memory, otherwise we will crash. Oh, I mean, no, we won't crash. If we don't release memory that we allocate for our program, it's gonna get lost, and it's a memory leak. And sometimes here it won't really matter since it's just 4 bytes. I mean, yeah, 4 bytes of memory. But if we were having like a ton of, like, let's say a gigabyte worth of memory allocations, we would see that performance hit when our thing, you know, closes, and then we restart it, and then it closes, and it just keeps adding more and more memory, and it never gets released back to the operating system, so it can't be used anymore. And it becomes, you know, we become, our system starts to choke, and if you don't have enough memory to do anything, you're just gonna crash your system and you're gonna have to reboot. A good thing to do before you use any pointers is you have to make sure that it's got something in there. So even if we didn't do this, we want to make sure that it is valid. So what we can do is we can just say if pointer name, or we can say if pointer name is not 0, then we're safe to use it, because that means that we have some kind of memory there. And the same thing we want to do when we delete it. Now this, if we don't check here with malloc and free, it won't really matter. If there's memory there, it'll free it. If there's no memory there and you try to free it, it won't matter. It'll just probably ignore it. I don't really know exactly what it does, but if we're using new and delete in C++, then it will crash. If you're trying to delete something that is not there, it will crash. So if you're using new and delete, then you pretty much want to check if there is something there before you delete it. And now we can actually step through this right here. We'll start there. So in here we can see that our pointer name is 0 right now. Once we call malloc, if we hover over it, we can see that we have something there now. And if we go back to here, we can see that this is our memory right here, and it's all, when you use malloc, it just initializes to some garbage values. It's usually for Visual Studio CD, 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 CD. If we wanted to initialize it to something else, we could by doing memset. Or just saying star pointer name equals 0 to initialize that value to 0 right here. So here it's going to check to see if we have a pointer, and since we do, it'll be okay. We'll print out whatever we need to print out right here, and then it'll check again. Right here we can see the printout. It's got that memory location and this value, which is the garbage value that I was talking about. If we continue, we can see that we're also checking it again, and then we're freeing it. Once we free it, it goes away, and this is our new value right here. And it just clears it. It's like something else. Not really sure what it is. I guess it's that number right there. And then we're good to go. Now, let's say we didn't allocate anything. When we try to run it again, we're not going to see the pointer printouts anymore, and it will not crash, because once we check here and it says, oh, this is actually equal to 0, it's going to skip that. So we don't have any issues there. We don't crash anymore. You can see it did not print anything but the variable name that we just changed, and it will not free it since there's nothing to free. So that's how allocating works. If you're using C++ and object-oriented programming, you want to use the keyword new to allocate in some cases. I personally don't really like to use the new keyword. And if you're working on games or anything like that, down the line, once your program gets a little bit more complicated and you have more memory to allocate, you don't want to keep calling new and delete all the time. So what you want to do is allocate a huge piece of memory like this, and just make some kind of memory manager that just gets memory from there. We will actually look into something like that later on the line, once we start our series for creating, like, I want to start a series for OpenGL or anything, in any kind of memory, not memory, video game development. But for now, we'll just use this. So in here, when we call a new int, it'll create a new integer thing. Here, when we use the new keyword, it automatically does the malloc and everything, and it casts it to the proper type. And there's another constructor right here where you can pass in a reference to a starting value that you want it to. So let's say we wanted 10 right there. We were just past 10, and it'll set pointer the value of the pointer name, not the memory address, but the value that is within the memory address. It'll set it to 10 right there. And once we are done using this, we want to use the keyword delete, and we want to delete it once we're done using it. So if we run this right here, we can see here that our pointer name is 0. Once we do that new allocation, we have our new address, but if we look at the value, it's 10 now instead of that garbage value. So if we go ahead and look at it in our thing, our memory thing, we can see that the integer that we have in this memory location, it is 10 right there. And then we'll print out as usual, and then here we have our address value, and we'll check to see if it's valid, and then we'll delete it. And you can see that it does the same thing. It does the same thing as the free. It just sets it to that same value that we saw earlier, and everything is nice and good. We don't have any memory leaks or anything like that. Alright, so I hope you guys learned a bit about pointers today. I think that's it for today. Later on I'll do more on pointers, but yeah. So don't forget to subscribe if you like it. Leave any comments about anything, and yeah, thank you. Have a good day.